and welcome to this session. In this video, I'm going to try and explain how we think logically and how we write the algorithms. So I'm just recording my screen. I'm typing out the algorithm and I'm explaining the thought process behind this algorithm. So first, I'm just taking a simplest example, and we will proceed step by step to understand how logical thinking and how algorithms are developed. So, first thing, what is an algorithm? Algorithm is the step-by-step instructions to perform a specific task. I'm not even talking in terms of a computer. Initially, I'm talking about logical thinking. So, logical thinking leads us to perform computerized tasks. Okay, so logical thinking makes us to write algorithms. What is an algorithm? Algorithm is the step-by-step instruction, step-by-step instruction to perform a task. So, what is a program? We say a program in normal man's terms. A program is, say, an annual day program. When you say annual day program, we know what are the components for the annual day program. We need the chief guest, and we need to arrange the venue. We have to find how many people are attending. We have to make all the arrangements. So that is the program. When you know the sequence for that program, you're going to do it very well. So similarly, logical thinking helps us in programming a computer. A computer can perform tasks. Computer can do multiple tasks, but we have to tell we have to tell the computer what to do when, so that we get desired output. For example, computer can add. It knows the arithmetic operation, but we have to tell the computer what are the numbers to be added, what are to be added, what operator to use, and where the output has to be displayed. So logical thinking or logical or algorithmic thinking. It involves identifying the input, identifying the process that needs to be performed, and the output that we want. Basically, logical thinking involves the um, deciding what are the input, what is the processing that is to be performed, and what is the output that we need from that particular program. So when we are able to decide this and we are able to write the statements that will help us to achieve this, we say we have done a successful program. So first, let us take the example of adding two numbers. I'm just taking a very basic example, just finding the sum of two numbers. Let me even specify the numbers for which we want to find the sum. Say, find the sum or total of 6 and 7. Now, how do we tell this to the computer? This is our problem. What is the input? Input is 6 and 7, and the processing we need is to add. The processing we need to perform is to add, and the output is the total of 6 and 7 is what the output has to be. So now let us just uh, say start. We say start, and what we need to do is we need three variables in which we can store these numbers. Say number 1, number 2, and sum or total. And now number 1 is equal to 6, number 2 is equal to 7, and total is equal to n1 plus n2, and we need to print the sum on the screen. Print the value of the variable sum. It has the total of n1 and n2. So thinking logically to find the total of 6 and 7, this is how we are going to proceed, and this is how we create the first algorithm. This is a very basic simple algorithm. Now supposing I just extend this to find total of any two numbers input by the user. Now what is the input? It is n1 and n2. It will be provided by the user in the screen. The process is the same. Process is we are going to add the two numbers. It is n1 plus n2, and output is going to be sum. We are going to get the sum of n1 and n2. So let n1, we are not going to say let n1 equal to 6 or 7. We are going to say accept n1, accept n2. Means on this screen we are going to display a message. We are going to say, tell the user, please enter the value, please enter the value for n1, then accept n1. The value entered by the user will be stored in the variable n1. Then we say print please enter value for n2. Then we say accept n2. The value entered by the user will be stored in n2. Then the process that we are performing is sum equal to n1 plus n2. Sum equal to n1 plus n2. Then we are going to print saying that the total the total of the numbers entered by you is sum, and we just stop, we end the algorithm here. So when we write an algorithm, we need to identify the input, we need to identify the process, we need to identify the output, and we have to give the appropriate statements in the correct sequence. So we are going to accept the value for n1, we are going to accept the value for n2, then we are going to find the sum equal to n1 plus n2, and we are going to print the total of the numbers entered by you is sum. The value in the variable sum is going to be printed on the screen. So this is how we think logically. See, the first algorithm we just said let n1 equal to 6, let n2 equal to 7, sum equal to n1 plus n2, and then we are going to print the sum. But we have to think the next step logically. It is not that only for 6 and 7, for every two numbers that you want to find the total. Suppose you are having to write a program, then it is going to be very tedious. There is no use of having a computer for that. So the purpose of the computer is when you can uh, use the same program. You write only one program, it can be used in multiple instances. Only in that case, the computer is more useful for us. So we have given a, we have generalized this algorithm, simple algorithm which we have used for finding the sum of two numbers. We have generalized, and we have given the next algorithm. We just extend that. We say please enter the value for n1, accept n1. Please enter the value for n2, accept n2. Sum equal to n1 plus n2. Then you print the sum. You have to identify the input, you have to identify the process that has to be performed on the input values, and you have to identify the output required, and you have to give the appropriate statements for this. Now, let us work on this a little bit more in the next video. This is a very basic, simple uh, algorithm that I have written for the very basic beginners, so that when you get used to the statements, then we can proceed further. So, thank you.